Today we're going to talk about something that many students of mine have been confused about over the past couple of years that I've been teaching chemistry stuff, and that is polyatomic ions. Most of them are confused because once we start talking about ions, they just see one element as an ion, and then all of a sudden there are these ions with more than one element in them, and so they get a little confused as to why they work. So I'm just going to explain what they are in this video. Polyatomic ions are when non-metals bond together, but they don't neutralize their charge. So they end up being a charged particle, a charged molecule. And so that means they're an ion. And so that means they can bond with other ions just as easily as a regular ion would. The majority of these polyatomic ions are negative. They're anions, okay? But there are a few cations as well. For example, NH4 plus, or ammonium, is a cation that's a polyatomic ion, and then something like sulfate is an anion. It's a negatively charged polyatomic ion. It's got sulfur and oxygen in it. Okay. There are some common elements that form these ions specifically. N is one of them. Hydrogen, oxygen, sulfur, chlorine, bromine, wrote down my list here. Fluorine's in them sometimes, iodine, did I forget? I forgot carbon. Carbon's also in there. And these are the ones that will, the majority of the time, be involved in our polyatomic ions. There are other elements that do it, but for the most part, they're going to be your non-metals that are on the top right part of your periodic table. They're the ones that like to do this. They covalently bond the most. Okay, so they covalently bond, but they don't neutralize themselves, so they can become an ion. So over here I have an example, okay, of lithium nitrate. Nitrate is this NO3 right here, and that's a polyatomic anion. Okay, and the reason that this becomes an anion is, okay, nitrogen starts off with 5 electrons, and then oxygens have 6 in their valence shell. So when they bond, it ends up looking like this. This is how the bonds work out. And so if you count how many electrons end up with each part, you'll find that there's some charges left over. So for instance, nitrogen ends up with 1, 2, 3, 4 electrons. Okay? Oh, I totally, okay. Yeah, so 4, and so it has 4 electrons hanging out around it. All right, and that would make it a positive charge because it is less than what it started with. Okay? Then we've got this oxygen down here. It's got 2, 4, 6, 8. And so it's got all the electrons it needs. It has a full shell, so it's perfect. It's neutral. Okay? But then both of these ones only end up with 7. They don't have enough going on here, and so they end up with overall negative charges. That means that this N is positive charge and this O is negative charge balanced out, but this O over here ends up with a negative charge left over. So this whole thing ends up being a -1. So I can bond with this lithium that's a +1. And there's tons of other examples of this that I could go through. No real need to, but just know that polyatomic ions, okay, are just covalently bonded things that don't neutralize, so they have to bond with an ion. They all have specific names, and there's a naming scheme for them. Okay, if you're in my class, you're going to get a chart that explains what all the names are. So when you're naming them, you'll have your chart that tells you what they're called. Okay, so you won't have to worry about that. If you're not in my class and you're watching this video, well, then you're going to either have to learn them, okay, or you can also print off a chart. They're readily available online. So I hope that you enjoyed this video about polyatomic ions. Thanks for watching.